So the difference of two squares is a technique that you can use for both expanding and for both factorizing. Let me just quickly introduce to you how this is the case. So if I was talking about the difference of two squares, I'd be referring to something that looks like this: a minus b, a plus b. Or if you want to make a bit more sense of difference of two squares, so if I look at a squared, if I do that, I've got one square, I've got another square. I'm just trying to find the difference of two squares. So you can see difference of two squares. So if I'm looking at this particular case, how do these two things link? So how does a plus b, a minus b, link up with this? Well, let's just quickly investigate this. So if you remember from your videos, FOIL, a times a times b times a, b times c. So what do we get when we expand this? What we get is a squared minus ba plus ba, and then we get minus b squared. And look what happens when we cancel this out. Cancel, cancel, and what are we left with in this case? We're left with a squared minus b squared. So you can see that there is a relationship between this initial thing of a minus b, a plus b, and a squared minus b squared. So in other words, every single time you say something that looks like a squared minus b squared, you can quickly just use a shortcut method and just go a minus b, a plus b. So let's apply that to a couple of questions now. So what we have is p squared minus 36. And the question here is to factorize this using the difference of two squares. First, let's understand what our rule is. So our rule is a squared minus b squared that's equal to a plus b, a minus b. Some of you might be wondering why I switched around the signs. It doesn't really matter which sign goes first. Okay, so we've got p squared minus 36. Okay, let's have a look at our values now. What is our a value in this case? Our a value is p. And what is our b value? Our b value is not 36, but rather 6 squared. So you can, well, let's just rewrite this as p squared minus 6 squared. So you can see this is a difference of two squares. So b in this case will be 6. So if we were going to put this into this rule right here, what we would get is we would say that this is p plus 6, p minus 6. And if you expand this again, you'll see that it comes up with the original expression for that particular case. Let's look at the next example. 4n squared minus 49. So I'm just going to take this a bit more slowly, this particular question, because it's important to realize that if we want to apply the rule, b squared, that's equal to a plus b, a minus b. If we want to apply this rule, we need to be sure that we're using the right things. So how do we write, what's another way of writing 4n squared? So another way of writing 4n squared is by saying 2n squared. Because if we square the 2, we get 4. If we square the n, we get n squared. Now I'm just going to put a minus there because that's what the question has. It's a minus between them. And what's another way of writing 49? Another way of writing 49 is by writing this as 7 squared. So once again, what is your a value and what is your b value? Difference of two squares, we can just apply this to the rule, so this becomes 2n plus 7 and 2n minus 7. And that's the fully factorized form in that case. Likewise, with the next example, let's do exactly the same thing. What's another way of writing 25x squared? Oh, I do apologize. This question should actually be a minus because we can only factorize this using a minus. I'm just going to quickly change this. Yep, there we go. So, what's another way of writing 25x squared? We can write that as 5x squared, all of that in brackets. And what's another way of writing 16y squared? We can write that as 4y, but in brackets, squared. Because if you square the 4, you get 16. If you square that y, you get y squared. So in this particular case, what is our a value and what is our b value? This becomes, we can use the rule a squared minus b squared. That's the same as saying a plus b a minus b. So in this case we have 5x minus 4y, or you can have plus there, whichever one you want, 5x minus 4y. Let's look at the next example right here. This one's a bit tricky because we've got to the power of 6 now. But never fear. What we're going to do is we're going to do exactly the same thing as what we've been doing. What's another way of writing 16m to the power of 6? Well, I'm going to be writing that as 4m to the power of 4 brackets squared minus n to the power of 4 squared. Sorry guys, this is supposed to be 3 to the power of 3. Oops, that wasn't supposed to happen. So that's 3, that's 3. Sorry, because if we use our index laws, 2 times 3 equals 6, 2 times 3 equals 6. That's how we use the index laws when there's brackets. So in this case, our a value is that, our b value is that. We use the difference of two squares shortcut formula, and we get 4m cubed minus n cubed, and then the other brackets will be 4m cubed plus n cubed. Okay, now let's look at the last example. The last example, we're going to be actually reversing it. So it's actually put into the perfect squares, difference of two squares brackets at the moment, but let's reverse it. So we have to be really careful when we're determining the a values and the b values for this particular case. Alright, so let's just rewrite this here just for a second, just to clear things up. Now, you'll notice that one of them has the minus and one of them has a plus in front of it. You need to be sure that the one that has no changes in the sign is in fact your a value. So usually in the previous questions, our a value, you would have said, okay, it's the one with the letter. That's not always the case. In this case, it's the one that doesn't have the sign change. So it's going to be 6. So your a value will be 6. And your b value will be 3y. So let's put this back into this case here. So this becomes 2 brackets. So your a value is 6. So that becomes 6 squared. And that becomes minus 3y squared. So from here we can then expand, before we expand we'll just calculate these values. So this becomes 2, this becomes 36 minus 9y squared, and from here we expand the 2 out, and so what we get is 72 minus 18y squared. So the key thing you need to remember here is that the a value is always the one that doesn't have the sign change. So you can see the 6 doesn't have the sign change, but the plus 3y does. In all these other ones you can see the minus, the one that has the sign change, is in fact the b term. The b term, and yep. See you next video.